Hi everyone, welcome back to my channel. In today's video, I'm going to show you how to refactor our previous .NET MAUI CRUD project with SQLite into a clean MVVM structure. MVVM stands for Model-View-ViewModel. The model represents your data and database layer. The view is the XAML page the user interacts with, and the view model sits in the middle as the bridge. It holds all the screen state and it exposes commands for user actions. Your view simply binds to those properties and commands, which means there's no UI logic sitting in the code behind anymore. This makes your project easier to maintain, easier to reuse, and much easier to test. First, let's create a new folder called MVVM. This is where we'll keep all of our view models and helper classes. Inside this folder, we create a base view model that implements iNotify property changed. This class is responsible for raising property changed whenever a property value changes, so the UI can update automatically. All you need to do is call on property changed inside your property setters. It's a simple, clean foundation that every view model in the app can inherit from. After that, add an AsyncCommand class that implements a command. This lets us run asynchronous code safely from the UI. It supports both parameterless and parameterized functions, and it fully respects can execute, so buttons enable and disable correctly. Inside the execute method, we first check if the command can run. If it can, we mark it as running, notify the UI, execute the task, and then reset the state afterward. This helps prevent double clicks and keeps the UI in sync. You can also call raise_can_execute_changed whenever the UI needs to re-evaluate a button state. Overall, this makes working with async commands in MVVM simple and reliable. Now, let's create a folder called ViewModels, and inside it we create the employee form view model, which inherits from BaseViewModel. First, we receive the database service through the constructor, and we keep track of the current employee model that we're editing or creating. We also provide two commands, save command for validating and saving the employee, and cancel command for navigating back without saving. Keeping these actions inside the view model helps the page stay clean and free of logic. This view model also exposes the properties title, full name, position, and salary, all of which are bound directly to the form fields. Whenever one of these values changes, we call on property changed, so the UI updates immediately. And for full name, we also trigger raise_can_execute_change to control whether the save button should be enabled based on the user's input. In the constructor, we receive the database service, then create the save command and cancel command. Save command runs save async and only allows saving when the full name is not empty. Cancel command simply navigates back. The save async method handles all the saving logic. If the full name is empty, we show an alert and stop. Otherwise, we update the employee model with the form values. If the employee is new, we add it to the database. If not, we update the existing record. After saving, we navigate back to the previous page, and if that page is using the employee's view model, we call load async to refresh the employee list. Next, we create the employee's view model, which also inherits from BaseViewModel. First, we receive the database service along with a factory that allows us to create the employee form page when needed. We expose an observable collection of employees for the list, a search text property that reloads the data as you type, and an isBusy flag to control the activity indicator. We also define 4 commands: load command, add command, edit command, and delete command. In the constructor, we receive the database service and the page factory, and we wire up the 4 commands: load, add, edit, and delete. Load async retrieves employees from the database, applies search filtering if there's text, then clears and repopulates the collection. The delete async method first checks whether the employee is null. If not, it shows a confirmation dialog asking whether to delete that employee. If the user confirms, we delete the employee from the database and then reload the list. The edit async method first checks if the employee is null. If it isn't, we create the form page and load the selected employee into its view model. Then we navigate to that page so the user can edit the employee's details. Let's go back to the employee form view model. Here we create the load from method, which loads an existing employee into the form. If the employee is new, we set the title to add employee, otherwise we set it to edit employee. Then we fill in the name, position, and salary. The async method simply creates a new form page and navigates to it, allowing the user to add a new employee. This view model controls all the state and actions of the employee list screen. The page only binds to it, with no business logic in the UI layer. Next, open the employee form page.xaml file. Here we bind the page's title directly to the title property in the view model. The input fields for full name, position, and salary are all bound to their corresponding properties with two-way binding, so changes update the view model immediately. And finally, the save and cancel buttons are connected to save command and cancel command, allowing the view model to handle all the form actions. Now let's open the code behind for the employee form page. First, we use the query property attribute to receive an ID from the navigation route and map it to employee ID. We inject both the employee form view model and the database service and set the view model as the page's binding context. Then, whenever employee ID is assigned, we load the employee from the database and pass it to load from method. This allows deep links or navigation with an ID to automatically open the form with the employee's information already filled in. Now, let's open the mainpage.xaml file. Here, the search bar is bound to the search text property with two-way binding, so it updates the view model as you type. The collection view is bound to the employee's collection. Inside each item, we show the employee's name, position, and salary. And to make editing faster, we add a double tap gesture on the item that also triggers the edit command. We also have edit and delete buttons, both bound to the page's edit command and delete command. After that, open the main page code behind. Here we remove the old code behind logic and replace it with a much cleaner version that follows MVVM. First, we inject the employee's view model through the constructor and set it as the page's binding context. This allows all the bindings in XAML to connect directly to the view model. Then in the onAppearing method, we call load_async to refresh the employee list whenever the page becomes visible. Now let's go back to the main page.xaml file to continue setting up the UI. We bind the add button in the toolbar to the add command and we display an activity indicator that is controlled by the isBusy property. Inside MAUI program class, we register all the dependencies needed for our views, view models, and services. We add the employee's view model and employee form view model as transient services and use a factory to create the form page when needed. This setup ensures that the view models are created correctly and that navigation works seamlessly with dependency injection. And that wraps up our MVVM refactor for the .NET MAUI CRUD app. I hope this walkthrough helps you structure your MAUI projects more cleanly and keep your code easy to maintain. If you found this video useful, don't forget to like the video and subscribe to my channel. Thanks so much for watching, and I'll see you in the next one.